Hello, good day viewers. Here is another indeterminate form of a limit. Remember I told you a limit is said to be in an indeterminate form if you realize 0 divided by 0 or infinity divided by infinity, right? So we asked to evaluate this limit of this function 2 raised to the power of x plus 3 raised to the power of x divided by 2 raised to the power of x plus 1 plus 3 raised to the power of x plus 1 as the value of x approaches what? Infinity. So if you substitute infinity direct, you see this will be infinity, this one, this one, this one, all of them. So you will have infinity over infinity, which is in an indeterminate form. So what are we going to do here? We are going to simplify it a little bit. So here is our function. I would like to factor out 3 raised to the power of x plus 1 from both numerator and denominator. So to the top we have 3 raised to the power of x plus 1 outside, but remember to divide the 2 times by what you have factored out. We have 2 raised to the power of x divided by 3 raised to the power of x plus 1, right? Then plus 3 raised to the power of x divided by what we have factored out, which is 3 raised to the power of x plus 1. Then for the denominator, we do the same thing. 3 raised to the power of x plus 1. Inside, we have 2 raised to the power of x plus 1 divided by 3 raised to the power of x plus 1. Then plus 3 raised to the power of x plus 1 divided by 3 raised to the power of x plus 1. From here, you can see that our factors will cancel, right? All we have are this and this. Let us simplify them again. We have 2 raised to the power of x, 2 raised to the power of x divided by 3 raised to the power of x plus 1. Then plus, you can see this one have the same basis, so we take one base and subtract the exponents. We have 3 raised to the power of x minus the whole of x plus 1 divide by, we do the same thing down here. This will become 1, right? So we have this plus 1. 2 raised to the power of x plus 1 divided by 2 raised to the power of x plus 1. Then plus 1. So we have 2 raised to the power of x divided by 3 raised to the power of x plus 1. Then plus 3 raised to the power of negative 1, which is the same thing as 1 divided by 3. Divide by our denominator. Oh, sorry, this should be 3, not 2. We have 2 raised to the power of x plus 1 divided by 3 raised to the power of x plus 1, then plus 1. This is exactly what we have. So from here, we can apply our limits, right? Let me just plug in the limit from here. This is equal to the limit as x approaches infinity of the whole of this function. I want you to observe here, if you substitute infinity here and here, the denominator will be much bigger compared to the numerator, because the base here is 2 and this base is 3, and exponent, this is just infinity, but we have infinity plus 1. So this will be much bigger than this one, right? And remember that if you have a fraction, as the denominator becomes bigger and bigger, the whole fraction will become smaller and smaller, approaching what? 0. So the whole of this will approach 0, likewise this one, right? So this will become 0 plus 1 divided by 3, divide by what? 0 plus 1. This is only equal to what? 1 divided by 3 as our final answer. 1 divided by 3 is said to be the solution to this limit problem. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.